In this video, we're going to look at how our understanding of systems of equations might be able to help us to solve a word problem. So, for example, let's begin by looking at this first word problem. It says here, a sports equipment store is having a sale on soccer equipment. A soccer coach went in and bought 10 soccer balls and 2 soccer ball bags and spent a total of $155. So let's think there we have a soccer coach that bought 10 soccer balls, 2 ball bags, and spent a total of $155. We have a second coach. He bought 12 soccer balls and 3 ball bags, and he spent $189. Find the cost of each soccer ball and each ball bag by writing and solving a linear system. So let's just think for a minute. I could solve this word problem with several different methods. I could guess and check. For example, I might say, I'm just going to guess. Let's see. I'm going to just guess here that a soccer ball costs $10. And I'm going to guess that the ball bag costs $15. Okay, I could make a guess and then I could check that out. I could say, okay, Coach A bought 10 soccer balls. So 10 times 10 is 100. He bought 2 ball bags. 2 times 15 is 30. That means Coach A spent $130. Well, if I look back at the word problem, I see that Coach A actually spent $155. So I know my guess is a little bit off, but I could tweak that a little bit and I could continue to guess and test until I got it right. That is a valid method. However, we could put into practice what we've learned about systems of equations so that we could have a faster way to solve that. Let's think about if we were to write a system. Let's look at how that might be helpful. Okay, Coach A, he bought 10 soccer balls and 2 ball bags. Let's think about the linear equations that we've worked with. Each of them have 2 variables, right? They have an x and a y. Okay, well, we could make soccer balls our x, and we could make the bags our y value. So let's take coach number 1. He bought 10 soccer balls. That means he bought 10x, plus he bought 2 ball bags, so that's 2y, and he spent $155. There's our first equation. Now, let's take the second coach. Second coach bought 12 soccer balls, so he bought 12x plus 3 ball bags, so he bought 3y, and he spent $189. All right, now we have our linear system written. Now, let's think about, we have 3 methods. Would it make sense for us to graph this? Most likely not. Those numbers are pretty big, so that graph would be pretty large. Neither equation's written in slope-intercept form, so that's probably not our best method. Should we use substitution? Probably not. Neither of the equations is written in the format of x equals or y equals, so it's probably not our best bet. So let's think about elimination. Could we easily eliminate one of these variables? I would say yes. I noticed right away 2 and 3, they both go into 6. So let's change both of these equations so that they say 6y, and we'll use the elimination method. In order to make that top equation a 6y, I'm going to multiply by 3. So that'll be 30x plus 6y equals 155 times 3. And for time purposes, I'm going to grab a calculator here and solve that. That's 465. Now the bottom equation, let's multiply by 2 so that we can make that a 6y as well. 2 times 12 is 24x. 2 times 3 is 6. And 2 times 189 is 378. So we can now eliminate. If we subtract our 2 equations, we'll get rid of the y's. 30x minus 24x is 6x. 6y minus 6y is 0. So we've eliminated the y's. And 465 minus 378 is 87. Now, let's divide by 6 on both sides. and we find out that x equals 14.5. Now, I want you to think about that answer. We're trying to find the cost of a soccer ball. So if x represents the cost of the soccer ball, this means this is money. So the soccer ball cost $14.50. Can you imagine if we continued that guess and check method? Some of us probably would have gotten to $14.50, but that might have been a struggle for a lot of us. This is a for sure method to get us there. Now let's finish it out. Let's find out the cost of the ball bags. So let's take coach number 1. We know he bought 10 soccer balls. So he bought 10 soccer balls at $14.50 each, plus 2 ball bags, and he spent a total of $155. Let's solve that equation to find out the cost of the bags. 10 times $14.50 is 145. So we have 145 plus 2y equals 155. Let's take away 145 on both sides so that we have 2y equals 10. We get y by itself. We find out that y equals 5. Remember, y equals the cost of a ball bag. So the cost of our ball bag is $5. And now we have our cost. Setting up and solving a system was a much more effective method than guessing and testing. Both methods would have got us to the same answer, but this is certainly a quicker method to use. Now, let's look at one additional example. It says here 2 cars get an oil change at the same place. Each customer is charged X dollars for the work and Y dollars for each quart of oil that is used. So we're kind of already given an X and a Y. X represents the money, the dollars spent for the work, and Y represents the dollars spent for each quart of oil. Okay, so I'm going to go ahead and just make a note here. X is going to represent the money for the work, and Y is going to represent the money for the oil. Okay, the first car required 5 quarts of oil, and the total cost for that car was $22.45. The second car required 7 quarts of oil, and the total cost was $25.45. What is the cost for each quart of oil, and what is the cost for the work? So let's take our first car. Our first car took 5 quarts of oil. How much work went into fixing that car? We don't know. So X amount of work plus 5 quarts of oil, so 5y, and that person spent $22.45. Okay, the second car required 7 quarts of oil for a total of $25.45. So some amount of work on that second car plus 7 quarts of oil, and that car, the total cost was $25.45. Now again, let's consider our 3 methods: graphing, substitution, or elimination. Okay, graphing is a possibility, although neither equation is in slope-intercept form, so there's really no reason to go through the trouble of getting it to that format. Substitution, neither is written in the form of y equals or x equals. So elimination, again, is going to be our best bet, and this one is set up perfectly. All I need to do is subtract, and I will have eliminated the x's. So let's do that. X minus x is 0. 5y minus 7y is negative 2y. $22.45 minus $25.45 gives us negative $3. Now you may be saying, wait a minute, we can't have negative money. We can owe money, but let's look carefully at this equation. To get y by itself, we're going to divide by negative 2 on both sides. And when we divide a negative by a negative, we get a positive answer. So we get y equals 1.5. So x, let's think about that in a minute. X represented the cost of our work, and y represented oil. So what we've just found is y. We have found that the quart of oil is $1.50. Now let's use that to find the cost of our work. Let's take car number 1. Car number 1, we worked for X hours, and we bought 5 quarts of oil at $1.50 each and spent $22.45. So let's do 5 times 150. Let's see, 5 times 150 is 750. So X plus 750 equals $22.45. We can take away 750 from each side, and that leaves us with X equals $14.95. Remember, X is the amount of money we pay for the work, so the work cost $14.95. Now, it is wise, I didn't do it on either of these word problems, but it is wise of us, once we have found that solution, to go back and check it, make sure that it works in both of your equations.